Hello and good day to everyone. My name is Mohamad Syafiq bin KASMAZULI and my matrix number is AE101007. And now I will show you the simulation on design PID control system. First of all, PID is stand for the proportional integral derivative. So for the question 1, I need to design the block PID control for the system. So here is the block diagram for the question 1. In this block diagrams, we need to find the input and the output response signal, which the input is for the speeds in RPMs and the output response signal is the mechanical part of shaft speeds also in RPM. So the input that we need to put here is the 500 RPMs and also 1500 RPM. So first one, that put for the 500 RPM here. So here is the result for 500 RPM of the output response signal. And next, for the 1500 RPMs. So here is the result for 1500 RPMs. As you can see, the maximum value for the 1500 RPM is higher than 500 RPMs. Okay, next I need to design the manual tuning PID controller. So in manual tuning PID controller, it has a 3-part, which is the part one. The first part is P controller, and the second part is the PI controller here, and the third part is the PID controller. So for the P controller, I need to find the output, which is a relationship between the response of each controller versus the input signal of, or we mean the speeds. So the speed that we need to be put here is between 900 RPM and 1500 RPM. So first one is 900 RPM. So here is the result for P controller for 900 RPMs. And next for 1500 RPM. So this is the result for 1500 RPMs. The value is higher. And then for the PI controller, we need to put the input signal, which is between 900 RPMs and 1500 RPM also. So here I will run for the 100 RPMs, and this is the result for 900 RPM for PI controller. And next for 1500 RPMs for PI controller, here's the results. The amplitude, the height is larger than for 900 RPMs controller, PI controller. Okay, now for the PID controller, so we need to put the input here, which is 900 RPMs, and then run the simulations. So this is the result for the 900 RPMs, and then for the 1500 RPMs for the PID controller, we run the simulation, and here is the result for the PID controller for 1500 RPMs. So as you can see, the difference between the P and PI and PID controller is they have more gains. For the PID controller, which is 3 gain, while P is have 1 gain and PI is 2 gains. So that's all for the manual tuning controller. And next we are going to see for the automatic tuning PID controller. Okay, now I will continue the presentation for the automatic tuning PID controller. So this is the block diagram for the automatic tuning PID controller. So first one is we need to click the PID controller, and then after that we need to click tune here, and then it will show the graph for the automatic tuning PID controller, and then we need to update the block. So we click update the block, and we need to click OK and run. So then it will show you the graph for the automatic tuning PID controller. So here is the graph. This is the graph for the 900 RPMs and for the 1500 RPMs manipulation. So here is the graph for the 1500 RPM for the automatic tuning PID controller. And next, the question asks us to compare the result between the manual PID controller and also the automatic PID controller here. So I just do the diagram here, and then after we run the simulation, as you can see, this is the difference between PID controller and the automatic controller. So the subsystem 4 is referred to the automatic PID controller, which is the purple color, while subsystem 3 is referred to the manual PID controller. So from here information, we can get the minimize maximum overshoot, the rise time, the setting time, peak time, and error condition for system response. So that's all for me. Thank you.